Hello everybody, in this video we are presenting a demo of Eigen faces. We took about 200 images of celebrity faces. The images were aligned and principal component analysis was performed. What you're looking at is the mean face. The sliders correspond to the principal components of the data. So weight 0 adds the first principal component to the mean face. In other words, it is the first Eigen face. Now we know that the first principal component or the first eigenface captures the direction of maximum variation in the data. The second principal component captures the direction of maximum variation orthogonal to the first principal component, and so on and so forth. Let's jump into the demo and see how we can create new faces by adding different eigenfaces to the mean face. As you can imagine, the first principal component captures the background. So if you move this, because that is the direction of maximum variation. If you take a bunch of random images, you expect that the background to be the most variant, and that's what we see here. The first principal component captures the background variation. Now, let's look at the second principal component. You can imagine that in random images of celebrities, the hairstyle would be very different from image to image, and that's why the second principal component captures the hairstyle. So it goes from dark to light, long hairstyle. Now let's look at the third principal component. The third principal component encodes three things: the pose, the lighting, and a little bit of hair. So you can see that the face is turning from one side to the other a little bit. And you can also see that lighting variation happening from one side to the other. And of course, the hair also moves somewhat. Now, one interesting thing you will notice is that the eyes are constantly looking at you. And the reason is that if you imagine celebrity photos, when they are posing for a photo, even if the face is turned, they are always looking at the camera. And that's why you see the eyes are always looking at the camera. Okay, let's look at the fourth principal component. Well, it encodes short hairstyles. And it encodes more than short hairstyles. If you look at this hairstyle, it is dark and short, but you also see that the skin tone changed from lighter to slightly darker. And the reason is that if you have dark hairstyle, you're more likely to have a slightly darker skin tone. And similarly, if you have a blonde hairstyle, it is very likely that you have a lighter skin tone. It is capturing that correlation. Now let's look at the fifth principal component. Well, what does it capture? It captures the skin tone. You can see that it goes from lighter to darker. So this variation is captured by the fifth principal component, the skin tone. Let's look at the sixth principal component. Well, this is interesting. If you go on one side, you will see that this face is predominantly masculine. You can see the mustache has started coming up, the beard is there, the eyebrows are thicker, and as you go from this end of the slider, it becomes slightly more feminine. Fascinating. Okay, now let's look at the seventh principal component, and this too includes lighting. We all understand that lighting plays such an important role in photography, so it's not surprising that so many principal components are capturing different kinds of lighting. In this case, there is some lighting that is falling on the shoulder. It also captures, the hair and the pose to some extent, but lighting is predominantly captured by this principal component. Now let's look at the eighth one. This is also fascinating. You can see that the image becomes orange to blue. So it is capturing the color tone or the warmth or the coolness of the image. On this side, we have warm images, and on the other side, we have, kind of cool images, bluish tone. Not only that, this is also capturing the glasses, sunglasses. If you look at it, you can see some glasses have started appearing on the face. And on that side, on the other extreme also, you can see some hint of glasses. So that's quite very, very interesting. Now, let's look at this one. Again, we see lighting, but this one is capturing a different kind of lighting variation. This is capturing lighting from the top and the bottom of the face. So that's the ninth principal component. And the 10th principal component is kind of funny. It captures a whole bunch of things, including the pose and lighting. And if we had looked at other principal components, they would start capturing less important stuff beyond, the 10th principal components. So what we have learned from this demo is that these principal components or eigenfaces, when added to the mean image, can be used to produce completely new faces. And it's also fascinating to see what these things capture. For example, when we are looking at lower principal components, like the first principal component, it is very obvious what it is doing. It is very intuitive. But as we move to higher principal components, let's say the 20th principal component, it captures very subtle differences, and it also captures interactions between various concepts that we as humans think very logical, like lighting is a concept, hair is a concept, but these principal components don't see the data the same way humans do. They might be thinking about interactions between the data. For example, they might be thinking about how light interacts with the hair to produce an effect. And we humans think of them as different concepts, but the machine would think of them as the same concept producing an effect. So I hope this was a very informative video. I hope you liked it. Thank you so much.